let's create a new script. My custom ANN file that opens up a new script, and okay, so we'll try to solve a XOR problem today, but not using the conventional method we studied earlier. We use a multi-layer perceptron. Okay, so XOR problem using a multi-layer perceptron. This is the first time. So let us assume we have 4 clusters of data defined on a 2-dimensional input space. Maybe something like A, B, C, D, right? So A and C will be falling under one category, wherein you have to get the output 0, and B and D clusters we have to generate the output 1, 1. So obviously the classes are going to be non-linear. All right, so let's start coding using the MATLAB. Okay, so clear choose all CLC, and we'll put the format to compact. Right, then we'll go to a new section where we try to create the samples, right? So let us define the number of samples as, say, number of samples per class. We'll define this to be maybe 1000, and then let us try to define the offset between the classes. Class offset equal to, say, 0.6. Then we have to define the 4 different classes. Okay, so that should be, say, class A. Is equal to, I have to create x and y coordinates, so we'll use random, how many? 1 row, and the number of columns should be equal to the number of samples per class. Okay, num of samples per class. So many I need. So I need 4 classes, so I'll do the same technique we did earlier. So minus the class offset. Okay, so this is the first one, semicolon. I go to the next row and I create random of, once again, 1 comma the number of this per samples. So if you remember, we have to give a different value here. So value is a plus. So this creates the first class of the data. What I do now, I'll try to paste this itself, copy and paste. Okay, so now I'll go for a class B. Alright, in this class B, I just want to have a change. So the data set needs to be, say, plus. So first class is minus plus plus plus, then I'll do the plus minus plus, and say this is minus. Okay, and say this is the last class should be all both minus minus. So now let me define. Okay, this is class B. Sorry, this is class should be class C. And we have the class D. So let's run this to see whether we get this. Yes. So class A, you can see that class A has open here, and we are expecting how many samples? 1,000 samples of that class. Similarly, B, C, D, etc. Okay. So now, in order to understand whether we have treated this properly or not, let's try to plot. All right. So this is the creation of the class. So I write and visualization. So this is what the first part. Let's create a figure. It opens up a figure window for us. So now I need to specify what I want to plot. All right. So plot. So I want to plot the first class, that is class A data. Class A. What should be along x-axis? The first coordinate, first row. So first row, comma all the columns. Yeah. Right. That's this x coordinate, and also I want to plot class A, second row, all the columns along the second axis. And later you see I want to, let's say I want to keep a kernel. Okay, so I want to generate this data and plot this data with a plus sign and maybe black color. So I'll put k plus. Right, so okay, right, so this will be the first plot. But you see, I want to have grids as well as I want to hold, right? So grid, turn it on and hold on. This is because I want to plot other classes also on the same, very similar thing. So plot, this is class B data, first row, all the columns versus class B, right? The second row, all the columns. Okay, now let's try to plot it using a different one. So I put there. It's already hold on. I don't have to tell the hold on once again. The class C data, first row, all the columns, then class C data itself, the second row, all the columns. Okay, and now specify this. Let's say I want to go with the, okay, I will do the same classes because, right, every class I want to show them the same. So this class A and class C fall under the 0 category. Okay, so that should be, I'll make it as k plus. Okay, then plot. This is class D. First row, all the columns. Class D. Second row, all the columns with the second category type of plot that's given as D or okay, so using this I should be able to visualize the classes. Okay, let's try to run and see. Okay, this one. So here there was a, now So is it visible now? The data created. So you can see that, right? We have two classes clearly visible. So I cannot draw a straight line to classify all the four. So one option is that you can create two straight lines. Now I don't want to create straight line. I want to go with a non-linear classifier. I want to draw some graph which is non-linear, not a straight line. I don't want to classify using straight line. That's my fundamental idea. Okay, right. So let's see how this works. Let's go for it. Let's try to define the outputs. Okay, let's create a, okay, let's insert another section wherein we create the outputs. Target outputs. Okay, the target outputs. So let's try to define, right? We want to encode each of our clusters, right, by using a class, right? Let's define. So class A target, I'm going to give a target for class A as -1. I want the output to be -1. Okay, same thing I want to assign. So class A and C, we could see that class A and C were same. Okay, is also equal to -1. Then class B target value. Let's try to assign that as +1. Same thing goes with class B, target. Okay, hold on to this. Let's keep it as +1. Right. Now let us put all the values required onto, right, a target vector. So the target is equal to, assign it in the same way. So this is uh, okay. Target we'll put later because we have not defined the inputs, right? So let me define the input first. Input is equal to, so all the data which we have created so far, class A, class B, class C, and class D. Okay, that will be my input, right, to the machine. So this is class A. Concatenate that with class B. Concatenate class C, class D. So this creates your input, and I define my targets. Okay, that's the input target. So what are the targets? Let's define. So my first target, in the sense, whenever the output is from class A, whenever the input data belongs to class A, how many data we have? 1000 data, right, in this class. I want to generate the output equal to this, that is class target, right? Class A target. It should be that output. That's what I'm expecting. Correct? So how many ones do I need to create? I need to create 1000 minus ones. Right? So what I do, I simply write rip mat. Otherwise, you can create -1 into ones of 1 comma 1000. That's also possible, right? You can write it in any way, right? I'll show you something, right? Let's see what we can. One thing is that I can write -1 into ones of 1 row 1000 columns. So if you run this, let's check what. This means you have 1000 minus ones, right? You can see that all 1000. But I don't want to do this. I want, because this plus minus one can change at any point of time. So we have to write the most general format of the code. So for that reason, I'm going to write it slightly different. Okay, I'll use another command, repeat the matrix, right? You can specify which matrix you want to repeat and how many times. So A is not A, sorry, I think the class A target. This is my matrix whose value is -1. How many times you want to repeat? One row, and I want 1000, but this 1000 can change any point of time. So how did you get 1000? The 1000 came because of this, right? The class A data, right? So I just have to say length of class A, right? So make it just more general. So by just saying length of that matrix class A, that's all. So this creates now 1000 minus 1s, all right? Yes. But my data is not just 1000. What's the size of your actual input data? You say here 10, here 1000, class B another 1000, class C another 1000, and class D, right, another 1000, right? So now I have to create that. So what I do, I'll go to the next line, right? This is the line continue option in MATLAB, 3 dots. Okay, then you write, right? I'll write the same thing once again. This is repamat. Now I want to go to the other class. Okay, so that is class B target. Size is 1 and length of class B. All right. Then I think I need to close it. Bracket over here. Yeah. So we close the parenthesis to match that. All right. Then in the next line, rep match. This is related to the class C. So what I should generate? I should generate the values corresponding to class C. So class C target. This is 1 and length of class C. Then rep matrix. The class D target 1 and it should be small. Okay, now let's close this. So this creates the target vector. Okay, so we created the inputs and targets. So let me try to change this. This is inputs and target outputs. We created it here. So let's try to run this part. There is a mistake. Class line number 42. Yeah, sorry. Class C is expected to be oh, sorry. Once again, I made a mistake. Okay, now let's is there any mistake? Class B, class C, class D target. Let me run from beginning. Okay, now no. Yeah, okay. Now let's proceed further. Now, okay, I'm ready with my data. Okay, I'm ready with my input data as well as the target. Okay, so now the multi-layer perceptron can be designed by directly calling the feed forward network. That's the function name which we are going to use. All right, so in the next cell, we create and train the neural network. it's the function is called as a feed forward net. I'll write that. So here, uh, create and neural network. So we'll create a network. Say my neural network is equal to feed forward net. Okay, it's called as a feed forward net. I just have to specify what size I want. I'll say maybe this is 5 and okay. So we can get a details of what this exactly does, right? So I'll feed forward net. Let's check this. It's a feed forward neural network. Two or multiple layers can be specified, right? So normally we say that when I call this, I'm expecting what is the size and what training function you want, right? You can specify that. So normally you can write like 10 and train LL. If you want to change this, you can write two layers, two different layers, each layer containing different neurons. Definitely you can go ahead with like what we did now. So we called this instead of 10, we mentioned this to be right. We use a square bracket. We made an array 5 and 3. So that indicates 5 in one layer, 3 in the other. Okay, so that's what. So anyway, any other help you want, you can use this. Okay, right. Also, you have the documentation related to this. That will also be very helpful if required. Okay, so we created the network by simply calling this. That's a built-in function. Now, whenever we do the training, right, we have an option to tell whether I have certain data set. For example, now I have data set which is corresponding to say 4,000, right? I have a data set of 4,000 data samples. Now, in the training process, there are the whole training process can be divided into three different stages. First stage is a training, second stage is validation, third stage is a testing, right? That can be defined if required, right? So I'll just show you. Previously, I think I never showed you that. That's why I will include that. Okay, so that is okay. This is my ANN dot. You have to divide your data set into training, validation, and testing if required, right? So I'll show you that. Uh, I think we have right divide the parameters first. This is divide div yeah, divide parameter. It's just PRAM. Then you say I want to perform the training part. So this is training ratio, right? So I'll maybe for the time being, let me write 0.67. Let's see. Okay, I'll show you what are the options we have. Other options we have. So my ANN. I think we define my ANN capital. So divide the parameters. Now after the training, I can go for validation. So that is called as VAL ratio, right? Out of your, if your data set is considered as 1, what portion of that you want to use it for training, what percentage you want to use it for validation, etc. So maybe zero point 0.7 is over, I'll make it 0.2. So total become 0.9. I have 10% left, that is 0.1. I want to use it for the testing. Okay, net sorry, it's a my ANN is a network dot divide parameter. Now I want to use a ratio called test ratio, right? It's the remaining one, that's 0.1. So this is one option. I'll show you the what else you can do. You can define this, and if I try to make this as 1, let me assume, right? You simply make this 0, okay? Because I don't want to perform any uh, validation, any testing by itself. I want to do the testing manually. That's also possible. Okay, right. Now I'll go for the training part, right? The training is by using train function. So it's going to generate the outputs such as one is the updated network. I'm going to call it by the same name, that is my NN. It also generates another output, say the training ratio, okay, and the output and the error. So these are the values which I'm going to get. This is equal to the function is train, pass the parameters required. First one is the neural network. What is the input and what is the target output? So we already have defined them as inputs and the targets. So input comma target, right? So you can see here this is the input and this is the target, right? Input and the target are both are already defined. Input comma target. Okay, so let's look at the train function. Let's look at the details once, right? So that is have train. Yeah, it's a huge function, can be used in many other. So you can see that the net is the network. TR, what they have called is the training record. Anyway, we'll run that and then we'll see. It also can generate many other parameters. Okay, right? So they also have given many examples, right? Please go through this for more details. Okay, about what exactly it's going to be. Right? So we perform the training using this one, right? And let me say, once this is done, I want to visualize my network. So this is view of my EN. Okay, let's check whether this is going to work first. All right. Okay, so that means it's running. We are getting the output. Fine. So let's move further. In the next step, we will try to plot the target, the network's response, to see how good the network has learned about our data, right? Has it learned something, or it's still it requires some more training? We can identify by just doing another plot. Okay, so plot the targets and the network response. This is the next cell, right? So I'll write plot the targets and the network response. Okay, so already there is a figure 1. I will call another figure here because I want to plot it in a new graph. All right, so two things I'll try to plot. One is that the target, and one more will be what we have learned so far. That's a y, right? So I plot, let's plot the target. So t, it's horizontal, I want to make it vertical, so t dash I'll okay. Let's try to make it wider now by doing line width by using the line handle called as its line width. Specify the line width you require. Say 3. Right? Line width 1 is default. 3 means more thicker line, so that I can it can be seen easy. Okay. And after this plot, I'll hold on in this graph. Then I'll plot another one. This is plot of see the output. Okay, so just now we got an output of the network, that is C, that is defined as Y here. So that Y I want to plot. Okay, again that was vertical. We'll make it horizontal by taking a transpose. And okay, let's give a different color so that we can visualize this R sketch. So this will be plotted in the red color, and I want the graph which we plotted earlier, right? That is the plot of the T dash with the thicker line should coincide with this if machine has learned something properly. Okay, that's what is my yeah. Now let's give okay, let's give a legend saying that what has been plotted, right? What is uh, what we are plotting first? It's a T. T is a target, right? So my first plot is target, and what you are plotting next is the network's response. I'll write simply ANN response. Wherever possible, it will put the legend in this case. And okay, let's see what happens. I simply run this part because previously we already have trained, so this should work. Running. That's not coming. Just a second. This one, let me check. Even for me, it's just a blank figure. Or let's give a different figure name. I think the figures are being overlapped. Okay, so I call this as figure 1, the previous one. Let me call this as figure 2 and check whether that's good. This is the second figure. Alright, let's try to run from the beginning. And once, yeah, this comes. Alright, so this is fine. And run it once. Training is done. And once the training is done, okay, there is some problem. Yeah, that's because I think I defined T here, but I think that's actually the target. Okay, so it's not T. It's actually target as per our. Yeah, okay. Something. Can you see the graph? Right. Okay. So on that graph, you can see actually two different graphs have been overlapped. Okay. The first one is Okay, I think I can revert the color so that visibility can be increased. Let me try that. Okay, so this is what I want. This. So R and I also include the line width different value. Let me make this as line width 2. We'll make the line width as say 3 for this. Let's see. Yeah, now it's more clear, right? So you can see that the dot lines is nothing but that's actually the response. The red color line what we see is because of the response. The other part which is not red the is the curve corresponding to the target. Both of them have been overlapped, because of which, right, we get a curve like this. So this means machine has learned something. You can see that the upper limit, the highest value on the upper side is +1, because two classes are +1. You can see from 0 to 1000 it is -1, 1000 to 2000 it is +1, and again -1 on the other side and the +1, right? Okay, so this says that yes, whatever we were expecting, machine has learned that. Okay, but that's not my problem solution ultimately, because I wanted to see something on this curve, that if I see something, some classification that is happening on this curve, then I can say that yes, right, that more visualization is expected from our side. If only by just plotting that, it's not sufficient. All right, so let's try to plot something more. Right, plot the classification result on that input sequence graph which we had created earlier. Right, I want to try to plot something over there. Is it possible to plot? Let's check. Okay, so uh, now what I want to do is the plot the classification results. So, okay, now, so first let's create the same grid which we had created earlier, and then we'll try to even put some colors over there, and then let us try to bring the what you call the classification back over. All right, so first option is to create the required grid. All right, so let me try to do a variable called as a span, and in this span I want to create the grids from say -1. So starting from -1, I think I wrote 1. Sorry, this is -1. Start from -1. Increment with 0.005. Let me keep it very small so that I want to visualize more clarity of that. Okay, and let me say I want to go till 2. Let's see whether this works. If not, we have to change it. Okay, so you know that we have what is called as a mesh grid. There is a function which we learned in the basics of MATLAB to create a grid of required size. All right, so let's try to create the grid now. So I'll call the grids as P1 and P2. Those are the outputs of the grids. Is equal to, call the function. So if you're not able to recall, go to the help space mesh grid. Okay, that's going to give you the idea, right? In the command window, you can type help space mesh grid, right? So you have to give the x and y size, so that I keep same as span, comma, same x-axis, same y-axis, similar size of x-axis and y-axis. X-axis also varying from -1 to +2. Y-axis also I want to vary from -1 to +2. This is the meaning. Create a mesh grid of spans, comma span indicating x and y coordinates. The result comes in P1 and P2. Okay, fine. So that's okay. Now create take okay, let's do one thing. Let me run this part and show you what exactly is happening here. So I run this section and I can show you the okay, let's see the P1 and P2 in this. So P1 is, you can see the P1. Okay, P1 is like this. It has actually starting from -1, right? You have created till 2, -1 to 2. Same thing with the P2. Okay, that's what is this. Now, what I do, I'll try to club them together, and then I'll put those. I will give those inputs because you see the values are actually -1 to +2. That's the actual range we actually created with our data set. If you can see, okay, let me just show you this part. Run this section. So you can see why I created -1 to +2 is just because of this reason. You can see, is it visible? No. Run again. Run again, it will come up. Okay, just 1 second. So I'm talking about this -1 to +2. Why was that? So uh, now you can see what's the range along x plus 2. What's the y-axis range? That's also -1 to +2. So for that reason, right, I'm trying now in my code, I'm trying the same thing. You can see here, it's -1 to +2 for x-axis. That has been used as span first coordinate of mesh grid, which is corresponding to x-axis, y-axis. Both are between -1 to +2. Is it okay? That I just wanted to justify why I okay. Now I did that. What I do, I'll try to I'll put them side by side. Okay, so something like this I can do now. It's like the concatenation operation. So create, say, some pp is equal to, I want to concatenate, so I have to use the square. So maybe this is p1. You can say that all by colon, right? Give a space, p2 all, and horizontal, make it vertical by doing a transpose. Okay, hope this works. Let's see. Okay, that is done. And now I will, okay, so I have to close this otherwise. Okay, this is done. Now simulate the neural network with all these inputs. See this, if I'll run this part once again, I'll show you what exactly is happening. So I run this section, I get a PP here. So you see, this is actually right. This is the data set which I have created now. Okay, so complete data set has been created. Right, I'm running this now. I'm going to pass these values 1 minus every number which I have created, I'm going to pass to the neural network. That's all. So how do you simulate this? How do you get the output? Output can be, right? So uh, predicted output of the neural network is nothing but I pass the input PP to the network. So how do you do that? It's I think my ANN of PP, right? This means the PP is given as input to the machine and machine will predict. So okay, now what I want to do, I want to visualize what is happening. I want to see the classification happening. Okay, so classification region I'm going to plot once again. Okay, right, I will come back to the figure one that has been created. Okay, I call back the figure one which was created earlier. On that, I want to what you call show you or I want to overlay the results on that graph which is already created. Okay, so let's try to do that. So that means I call back this, and in order to plot a mesh grid like structure, the function is mesh. If you remember the various graphs we had studied in the basics of MATLAB, there is a graph called as a mesh. So mesh requires, right, both X grid and Y grids, right? So X grid is, I think we created as P1 and the Y grid is P2. Okay, anyway, these are the random names I have given. I'll correct the names according to the requirement. All right, so then so otherwise P1, P2 doesn't make any sense, right? So you can write, I'll update. So let's make it as, okay, let's create this first, later on I'll modify. Okay, then I have to say what should be plotted over there, right? So I have to plot the result of the required length. So I'll see this PP is of different size. I want to make the size same as this size. That is the span and span. That's my required size. Okay, of the result. So what I do a reshape of, because it's, you can see that all the points are in 2 rows n columns format. I don't want that, right? I want something like 4,000, 4,000, 4,000, 4,000. Like that I'm expecting. So for that reason, this is a reshape. It's a reshape of what's your output? I think output is predicted output. The predicted output, right? Convert that into the length of whatever x and y axis we created. I think that's the span is 12. This is the size of x. Again, length of span. 1, 2. I need another bracket. Okay, let's see whether this works. I gave a color code to this. So you have seen another word called as a color map, and various versions of color map also we have seen. You can give a hot, right? I'll give a cool. Let's see. Okay, let's see what happens now. I'll call the figure one once again because I closed that, so it's not visible as of now. I'll run this section so that I can get the figure one, and then I come back here and I'll try to. Okay, I'll try to run this section. Yeah, it's coming, but only the colors are different than what is expected. But you can see that there is a classification that is happening, right? So these two are one class. I think other color is not visible because of the color map. I think for color map I have to give another command called as view, because of that mostly it's not visible. Right, let's see. Let me check this. Visible. Spelling mistake. Sorry. It's not color U. There's no U here. Color U. That's the mistake. Still, what's it? Nothing changed. What's the color we gave on the? I changed this to blue colors and stars. Let's see whether that's going to work, because I think the shape we define itself is not. It should be expected. It's usually I'm expecting something. It's not coming. Let's check once. Okay. Let me change the color. Maybe if it is blue, it's not visible. Let me change back to the black itself, but with a different shape. Okay, so let's try to run this. Very sure. Here only pluses are there. So I was expecting the other colors. Let me check. It's being plotted, but we cannot see for some reason. But anyway, our main intention was to visualize the boundaries, right? So you can see that it has decided a non-linear curve which separates the two classes, and it's very clear. Okay, so that was our basic motive behind today's class, wherein our intention was to generate the data set corresponding to two different classes. The simplest problem was an XOR, right? So we did that, and then we tried to uh, design a neural network which could learn this classification, and also later on we could even visualize the non-linear curve it has generated. Okay, I hope this is useful and we could learn something.